Hey everyone, today we'll be going to do a lead code problem number 814, that will be a binary tree pruning. So first we'll go with the problem statement, what it will be given to us. It's a binary tree problem and we have been given a binary tree that will only contain the value 0 and 1. Now what we have to check it if it's like if it's a 0, okay, and if it's the last node that contains both of its left child and the right child as null, so we'll just remove this node and whatever the resultant will be, and we will do this for all the nodes. We'll check this for all the nodes and we'll be returning the final tree. That will be the problem, this binary tree pruning. And this you can also be try doing this non-recursively and recursively. Both there are both ways are there. In this video we'll be discussing about it. The we should be moving to the second example of this. Is like you can see this is a large tree, it was a small one, and here we will be finding the four nodes that will be first now this will be going with some traversal. Okay, either you can go with the pre-post or the three traversals are there, the basic one. You can go with it, and we have to check for every node. Like if our node, like both of its left child and the right child, it's null, so we'll be removing this. Then here both of its left child and the right child is null, so we'll remove this. So when this two will be removed, then this will also be containing null on both of its left and right sub child. Okay, so this will also be removed, and similarly with this node also. So ultimately this only the three nodes will be left with the one value. Okay, coming to the third example, here also just the same, left and right child will see if it's a null, we'll remove this. Okay, here also we'll do the same thing, and other nodes will not be changing anything. Okay, it will be as it is. So moving to the problem coding part of it. Okay, see, only the root will be given to us. Okay, now we have to check in this tree. Okay, so first the corner condition will be checking, like if the root has been given a null to us, so we'll not be doing anything. If my root is equally null, it's given, so we will be just returning the root over here itself, and will not be proceeding with our further program. Okay, and if my the root now this corner condition has been checked over here, and we will be moving. First we will go to the left child, leftmost child of it. Okay, I understand. I'll consider the second example. First we'll go to the leftmost child of it. First node, it will go to the left, then this node will go to the left, and this node will go to the left, and then we'll be moving to the right, and then the root. So we are basically left, right, and the root. We are going with this traverse. Okay, so if my root dot left, okay, and we'll be calling this function root tree, and here we'll be passing the root dot left, and we'll be calling the root the function again with the root dot left, and we'll be storing to the root dot left. Okay, and root dot right, root dot right is improve tree. Okay, the same function with the root dot right call, with the root dot right call, and then we'll be checking if my root root dot left it's not equal to null, or if any one of it's not null, then we'll be returning the root. Okay, and root dot right if it's not equal to null. So if this is the case, then we will return the root, else we'll return the null. And not this should be null, and the value of it should be 0. So if my control of the program is coming over here, that means there is a root which contains both of its child as a null, and then we are checking like if root dot val it's equal to 0, then we will be returning the null value over here. Okay, and ultimately we have to return like a tree node. So after removing all the nodes, processing everything, ultimately it will be our first pointed node that we have to return, so that our whole tree has been accessed. Okay, because we are just checking and doing operation in the nodes, we are not disturbing the whole tree. Okay, so we have to return this root over here, and yeah, should run and check it. And here we are going with the left, right and root kind of traversal. So it's a post order traversal that we are following over here. Okay, here it was just a spelling error, so we'll be proceeding with it. I was telling like we are here, we are following a root left right GHT. Okay, right. Yeah, here we are following a left, right, and then we are processing the root value. So it's a post order traversal. So yeah, it's worked for one test case. We'll be seeing for other. Yeah, got the got it for all the test cases passed. So yeah, you can do check this out, try it on your own, and try to do it in a recursive this is the recursive part. Try to do it in an iterative manner, so that you are more clear with the functioning of this binary tree. And I'll be posting it in my next video, that the iterative traversal of this binary tree pruning. If you have any doubt or any idea to solve this particular problem, or the iterative one only, so you can do put that in the comment section. Till then, thank you.